Hello friends, today I will discuss the linear incremental encoder. In this topic I will cover the necessity of this, definition of this, construction of it, principle and its operation and their applications. Necessity, it is nothing but a internal type of sensor used in the robotics, and it is used to measure the position, speed and direction of the joint or its associated object connected to it. And when it comes to the definition, it is nothing but a device which measures the position, speed and direction of the joint movement, and its construction majorly consists of 5 parts. One is light sources, the other is alternate transparent scale, third is photodiodes, 4 is microcontrollers, 5 is counters. The general diagram of this linear incremental encoder looks like this. This is the transparent scale, alternate transparent scale. There are dark strips, there are transparent strips. So their width will be same, and this is the scale. And here there is a set of photodiodes called phase A diodes. Similarly, another set of phase diodes can be kept. We call them as phase B. And this phase A and phase B photodiodes will produce the pulses, and those pulses will be transferred to the microcontrollers, and microcontrollers will transfer the pulses to the counters, and counters will count the number of pulses generated by phase A and phase B, and based on the position of these pulses, phase A and phase B, the direction of the joint with reference to the reference can be decided. And this scale is connected to the prismatic joint. This is also called linear joint. So the diagram of the linear joint or prismatic joint is like this. On this joint, this scale will be connected. So once we connect the scale, it looks like this. And this is the scale, transparent scale, and this is the light source. One more light source also present. One we call as corresponding to phase B, the other corresponding to phase A. And this is the reference position of the joint. If the joint moves to the left, it produces the pulses. Similarly, when this joint moves to the right, then also the photodiodes will produce the train of pulses. Based on the number of pulses produced and the phase difference between the phase A and phase B, the direction of the prismatic joint movement can be decided, and also based on the number of pulses, the distance traveled can also be determined. And similarly, by knowing the time for the pulses to produce, then the speed of this joint also can be calculated. So suppose phase A joint or phase A photodiodes produces the pulses like this, and phase B produces the pulses like this. In that case, the meaning of that is phase B is leading the phase A. That means the prismatic joint moves reference point to the left side. Suppose the phase A leads the phase B pulses, then we say the prismatic joint moves from the reference point to the right side like this. As I explained earlier, we can see here phase A pulses will be transferred to the or connected to the microcontroller. Microcontroller will transfer the pulses to the counter, and counter will count the number of pulses produced by phase A photodiodes set. Similarly, phase B photodiode set produces the pulses, and they are connected to the microcontroller connected to the counter, and counter will count the number of pulses that is produced by the phase B, and based on the phase difference we can say the direction of the movement of the joint, whether to the left or to the right with respect to the reference point. And the same thing whatever explained is shown like this, and one side there are photodiodes, and this side the light source. So once this light flows or goes through this transparent slits, then that will fall over the photodiodes, and photodiodes will glow, and those glowing diodes set will produce the pulse. So there are two sets of photodiodes. One is called phase A set, the other is phase B. And similarly here two light sources will be present, and this is the scale. And this scale is attached to the what is called the prismatic joint. When the prismatic joint moves, automatically the pulses will be produced. And the pulses are connected to the microcontroller, and microcontroller will send to the counter those pulses, and the counter will count the number of pulses. And if you know the number of pulses and the time taken for those pulses to produce, then we can calculate the speed, because the number of pulses produced is directly proportional to the distance traveled. Once the distance is known and the time taken for the pulses is known, the speed of the joint can be calculated, or that is also called velocity of the joint can be calculated, and the direction is decided by the phase difference between the pulses produced by the phase A and phase B. When it comes to the application of this linear incremental encoder, it is used basically in the CNC machines, jig borers, grinding machines, press brakes, milling machines, etc. So let me summarize once. So this linear incremental encoder connected to this prismatic joint, that is its scale will be connected over it. When the joint moves, automatically the pulses will be produced on the phase A and phase B photodiodes, and those pulses are transferred or controlled by the microcontrollers, and microcontrollers will send those pulses to the counter, and the counters will count the number of pulses. Based on the number of pulses produced by phase A and phase B, the distance traveled by the prismatic joint can be determined, and if the number of pulses produced and its time taken is known, then the velocity of the moment also can be calculated. And based on the phase difference between the pulses produced by phase A photodiodes and similarly phase B diodes, the direction of the movement of the linear joint with respect to the reference point can be decided, as I discussed earlier.